The broadcast is now starting. All attendees are in listen-only mode.
This is William Henningsen. I'm a board member for the IAFSM. It's a professional association based on 3D documentation and 3D scanning, in particular, of crime scenes and crash scenes or forensic situations. This is part of our webinar series, and today we're hosting Chris Kercheval from ZNF. ZNF produces laser scanners and has produced laser scanners for a number of years. Chris himself is a technical sales and support engineer with ZNF USA. His day-to-day job includes hardware and software training, as well as assisting in sales and support. He has over 10 years of experience of field surveying. At one time, he had his own consulting business, and he's been involved in mostly upstream and midstream oil and gas survey. He has various areas of work history, mainly focused on problem solving and customer service, and he's been with ZNF for 2 years. The topic of his webinar today is ZNF Scanning, the Hub of Forensic Mapping, and Chris in particular wants to talk about the new ZNF Imager 5016 and how it fits into their idea of how forensic mapping should be done at scenes. So Chris, I'm going to turn it over to you. Everyone, I'd like to remind you to enter your questions as they may come up in the chat box. We were having some problems with the question function, and so it may not work. We should be able to see questions as they come up in chat. And I also want to remind everybody that this is going to be recorded and should be presented on the IAFSM website at iafsm.org. Thanks. Chris, it's all yours.
Thank you, Will. My name is Christopher Kercheval, and this is ZNF Scanning, the Hub of Forensic Mapping. A little bit about the company of ZNF. ZNF USA is a United States subsidiary of ZNF Germany, which was founded in 1963. They're the inventor of the insulated wire ferrule and have been in the laser technology since the early 1990s. The most recent scanners have an internal navigation system, which allows for on-site registration ability. ZNF USA was founded in 1998. And in 2007, relocated to a larger office in Bridgeville, Pennsylvania, where we have a calibration room for the calibration of scanners, as well as a service room for said scanners, warehouse for the wire ferrules, and a demo and conference room for in-house visitors. A little timeline of ZNF and the products that we offer. Starting in 1992, we came out with the LSR camera, and going up all the way to 2016's model, the Imager 5016 series. Of note are the Imager 5003, 5006, and 5010 units, which were also known as the HDS series from our Leica OEM partnership. On the bottom, we see that we also have profilers, which are used for mobile mapping applications. The Profiler Duo on the bottom middle there from 2009 is used by MTA, or the Mass Transit Authority in New York City, to maintain their railway system. Some of our units you may have seen before include the Profiler. This particular photo shows 2 units mounted onto a Pegasus unit for the Leica system, as well as a HDS unit from our OEM partnership with Leica. ZNF scanners are industrial grade. The interior portion is made out of a milled aluminum, and these 2 particular scanners have come into us for service. They've been extensively used in the field. These are both still operational units. The laser system itself is as accurate as some of the newer models that have come out, but as you can see from these 2 pictures, they are built to stand the test of time. So a little more in terms of how this is going to be applicable to forensics. Forensic mapping can be defined as a combination of sciences used to collect evidence at the scene, essentially a forensic survey. A goal then of forensic survey would be to collect all of the evidence in an effective and efficient manner for further examination. So let's start with why ZNF would be used for forensic mapping. The why would be the need to ensure a complete coverage in field where time and access are limited. How you would do that is using the blue workflow, and the products that you would use would include the Imager 5016, Laser Control Scout software, which is optimized for mobile use, VESA software for a deliverable, and peripherals such as a dot product, Mantis Vision, and a total station. So the hub of the forensic mapping is the Imager 5016 unit. Laser Control Scout is used to control the scanner and view the scans. The Mantis and the dot product are used for areas where it's just not feasible to get your scanner, but you still need to collect data in those areas. And that data can be sent directly to the scanner and registered in the field using the Blue workflow, and then exported out to VESA for your deliverable. So a little bit about the hub of forensic scanning. We have the Imager 5016 unit. Some of the key features here are that it's very accurate, it's quick, and it's very lightweight. An accuracy of 0.004 of a degree. Resolution is 1.8/10,000 of a degree in the horizontal, 2.6/10,000 in the vertical. And the time that it would take you to collect 50 million points is 1.5 minutes. If you wanted a color point cloud, you can add another 2 minutes and 30 seconds onto that for roughly 4 minutes per scan setup, which is the equivalent of the average drive-through wait time in America right now. The Wi-Fi transfer speed is up to 240 megabits per second, meaning that your scan can download for immediate review in under a minute. And you can view those scans from a distance at up to 200 feet away from the scanner, meaning that you don't have to be on site and in the scene whenever you're viewing your scans. And the weight is under 8 kilograms or under 17 pounds. So it's a very small unit that is very fast, efficient, and lightweight, so you can carry it into scenes as required. A little bit on the spec sheet of the 5016 unit. On this one, we have an eye-safe unit that can have a range of up to 365 meters. It's highly accurate. And on the bottom, we have, of note, the linearity error is 4.6 millimeters at 365 meters, which is the extent of the range of the unit. It's 1/10 of an inch at 1,200 feet. To put that into common terms, that's the width of 2 survey range poles at 3 football fields. The resolution of the unit is the number of measurements that are taken, and the quality is the repeatability of the measurement. A lot of the manufacturers will give you the same information, but give it to you in a different format. So to kind of get an idea of what we're talking about, that would be the equivalent of, in survey terms, how many sets you're doing and how many times you're repeating them. For the resolution and the timing that we are stating, a 1.5 minute scan is giving you 10,000 pixels per rotation of the vertical mirror. We have a field of view of 320 degrees by 360 degrees, leaving only the 40-degree cone directly underneath the scanner as your void spot. And we have an IP rating of 5.4. The unit also comes with a dynamic compensator, which will compensate for tilt in every pixel of every line. Data storage is 128 gigabyte internal with 128 gigabyte SD card. We have an illumination system on our camera, which is a dedicated camera. The 2.5 minute recording time is 2 exposures, but can go up to 11 depending on the lighting conditions, so that your photos come out crisp and clear in every angle, in every lighting situation. We also have 2 hot swappable batteries, meaning that you never have to stop scanning in order to switch out your batteries. It can operate on one alone. And now for the how. How we would use the scanner out in the field. The normal traditional method of scanning would be to go out into the field, evaluate the area that you are going to scan, set up your targets, scan, and then transfer it over to a machine, take it back to the office, open it up in the software, register all of your scans together, review them, and then save them for the next step of the process. With the Blue workflow, you're able to do all of those while you're out in the field, meaning you're cutting down on your office time greatly. We do that with the Blue workflow. You would plan out your scan positions, connect to the scanner, collect the scans, and then you would open and verify them before moving to the next position to ensure full coverage of the area of interest. So let's go ahead and we'll see that happen in action. The only time you really have to touch the scanner is when you mount it to the tripod. After that, everything is controlled remotely via a tablet or laptop that you would already have available to you, utilizing the Scout software. What we see is the scan is taken and then downloaded immediately to the tablet for review. You can see there's no targets anywhere in the area that's being scanned. And with the IMU and GPS, you have full control over viewing the scanner as it moves from position to position. The scanner fits in the standard survey tribrac as well and has a laser plummet. So if you are working in conjunction with a survey crew, you can occupy the same point they did. And you can also occupy the same tribrac they did, the only difference being the height. So here we see as they're going around in this demonstration, the scans are coming in automatically and they're automatically being registered together. You have the ability to have the scanner follow you linearly from scan position to scan position, or if you're on a dynamic scene and you need to jump around and stay out of someone's way, you can have them be pre-placed and then make the connections yourself afterwards. Laser Control Scout is the heart of how all of that works in the field. Gives you the ability to do a target-to-target, cloud-to-cloud registration, as well as the automatic or manual pre-registration. Synchronization is a two-way sync. Whatever changes you make on the tablet to the scene are then transferred back to the data that is on the scanner. You can control the scanner remotely, as well as make annotations and links. If there's something of interest in the scan, you can immediately put a note on it. You can map the color if you needed to while you're out in the field. And you can also run filtering options while you're in the field as well. So you don't have to worry about going back and filtering noise out of a scene a day or two later when you get the opportunity to go back to the office. Some filtering does happen immediately as soon as the scan is downloaded, but ZNF Laser Control is a non-destructive format in that with 3 clicks of a mouse button, you can take everything exactly back to the way it was as seen by the scanner. We just hide the points that you don't want from your field of view, but none of them are ever deleted. And measurement tools are also available so that you can take measurements while you're in the field, and later you can save those as a DXF file for export into AutoCAD. One of the other benefits of the Blue workflow is the Mosaic retake. So with the 5010X and the 5016 models, you get the ability to get rid of unwanted people or obstacles that would be in your images. With the retake, you would click on the mosaic tiles that have the unwanted image in them, click the retake button, and the scanner will immediately go just to those spots, retake those images, and then stitch them back into your final image. There's no need to retake the entire point cloud and images all over again from scratch. Those images are also able to be exported. This is an example of an ICAM panoramic image that we took at the IAFSM event a couple of years ago in Orlando at the hotel, and these are able to be exported at up to an 80 megapixel. So let's look at how we can use these in areas of forensic applications. ZNF USA, in conjunction with the Pennsylvania State Police and Corporal Andrew Theowachter, did an event at a Pennsylvania State Police barracks where we found and then uncovered a clandestine grave. Here you can see we did not use a tripod for this particular scan. We wanted to get a little bit closer to the body or area of interest. And in this particular case, we're looking at the shoe that was found on the skeleton, and we also wanted to gain as much information as we possibly could before disturbing the scene. This is a close-up of the scan that was taken from that position, and here we can see a lot of ridge detail on the shoe itself. And this being an uncovered body that was scanned from above. level of detail, we can see vertebrae as well as the rib cage. Another area of application would be in traffic accident scanning. This particular photo is taken in Seattle, where our area of interest is the roadway down below. Here we see a bubble view of the same traffic scene as it was seen by the scanner. In terms of traffic, here we have a picture that was taken from the German police department where someone had put their car in a hedge. Other law enforcement agencies that use ZNF scanners are the FBI, the police in Brazil, as well as Japan. Here we have a scan of a mock car crash. Two people were so excited to come to work one day that they accidentally ran into each other, and so we decided to scan it. The level of detail that you can see here is quite good. We have a positive return on the tires, as well as you can definitely tell there's a little bit of a space in between the two. Yet another area would be for a metropolitan public safety planning. If there was an event coming up at the Sprint Center here in Kansas City where it was a politician coming to speak, or we were just looking to do some emergency escape planning, we can scan these areas efficiently and effectively with the Imager 5016 unit. With the mobile software, Laser Control Scout, you have the ability to open your scan in the 2D or the bubble view, select an area of interest, and then open that area of interest in the 3D view at a full resolution to ensure that you have a full coverage of all the areas of interest. This particular person had an accident in a parking garage, and we wanted to make sure that we captured everything that we needed, including any of the liquids that were on the ground or any other evidence that might be applicable later. So the Blue workflow, in addition to giving you the ability to scan efficiently and effectively, you also have the ability to include other products. Not all scanners are able to fit in small, compact spaces. So the dot product is something that is used in a up-close range of 2 to 12 feet. It's a near-infrared structured system. Once your scan is completed with the dot product, you're able to export it directly to the ZNF Imager scanner, where it is immediately pre-registered to the scan closest to it. You can open that scan and then do a manual registration so that when you're leaving the field, your dot product scan and your ZNF scan are completely registered together for one coherent point cloud. You're also able to export dot product scans in a PTS or a PTX format, as well as the native DP format. These integrate very easily with the VESA Arena 4D, LFM software, Recap, and other softwares that you may already be using. Another product that is recently available to use in the Blue workflow is the Mantis Vision. The Mantis Vision differs from the dot product in that this one is an infrared light system which works in any lighting condition from daylight to darkness. There's no scene preparation needed, and you can use the same tablet that you are operating Scout on for operating the Mantis Vision software. This enables you to save the data on the same tablet and import it directly to Scout for a registration. Now that you've collected all of your data, VESA Arena 4D is an excellent addition to the Blue workflow. You are able to take the ZF files in a drag and drop style format directly into VESA, where you can visualize the data, make any kind of animations that you would need. An example of where that might come in handy is if you're at a crash scene, you scan the crash with the ZNF Imager 5016. You're able to register those scans together. you're able to use either a Mantis or a dot product to scan the inside of the vehicle for full complete coverage, register those together, export them to VESA, and then animate the scene while you're still on site. These point clouds are then able to be shared with someone back in the office via the VPC creator in the point server. Some examples of the VESA software and how that would apply in a crash scene are shown here. These scans were taken by Pennsylvania State Retired Corporal Andrew Theowechter. We have an exemplar vehicle in the middle, a crashed vehicle on the right side, and then taking a slice at bumper height, we can do a crush analysis. Another scan taken by Andrew Theowechter with a ZNF Imager series scanner and then put through the VESA software. And of note on this one is the level of detail that you can see in the vehicles. The tires on the trailer to the bottom right, as well as the level of detail in the door on the upper right-hand corner of the scan. If you're not using VESA, some of the other software that you may have that has a native import capability would be Autodesk, like a Cyclone, MapTech, MicroSurvey, VESA, as mentioned, and you're also able to export in neutral formats to take to the next stage of your deliverable, some of the most common being ASCII, DXF for shapefiles, E57, PTX, PTS, and Recap. The Imager 5016 gives you a lightweight, highly accurate, fast piece of equipment that is capable of handling multiple areas of forensic application, and it gives you all of that in a very small package that's IATA certified for safety, 2 hot swappable batteries, 2 that come included, a charging cradle so that you can charge 2 in the car while you're using the 2 on the scanner in the field. You're also able to charge the 2 that are on the scanner if you have the ability to plug it in on scene. And all of your equipment fits into a very small case that in this picture we show next to a Leica C10 unit is about half of the size. For the laser control software, once you take your scenes back to the office, if you prefer to do your processing in a more conventional fashion, we have a comparison of laser control versus a competitor's software that has come out in recent months, where the rough number of scans would be 40. The time it would take to import those scans and process is 64 minutes versus 112. And then the time for export into a neutral format like E57 was 24 minutes versus 87. For a total time of 1 hour and 24 minutes, so just shy of 1.5 hours, versus 3 hours and 49 minutes, which is almost 4 hours. So you're saving yourself 3 times the amount of office time, and the scan acquisition time would be roughly 4 minutes to about 10 minutes. So a summary of the hub of forensic mapping would be that ZNF USA is offering an Imager 5016 unit, which has twice the range of our previous models, twice the accuracy of our previous models, and a smaller and lighter package with a very efficient workflow that gives you the ability to verify your scans while you're in the field. It plays well with other scanners and other peripherals that you may have, including survey data. So if you're on scene with a survey crew, you are able to import their survey data and use those points for registration. You can also make survey points out of the data that you collect and then export those as a DXF to be used in conjunction with survey data that may be collected on scene. You're also able to export our scans out into a format that you can use in the next stage of the process. And as we've shown, the products are durable. We have units that have been in the field for 10+ years. As the picture showed, they might not be as cosmetically pretty as they once were, but the quality of the data that comes off of them is still as good as it was when it came off of the factory floor. And show you a video of how all of that comes together. What can you do with data that is collected in under 5 minutes with no targets, and then put through a software such as VESA, or in this case Euclidean? We have a fly-through of a castle ruin, and this was taken with an Imager 5010X unit, and then the animation is done by Euclidean. We can see we have no targets put up, and along the driveway, the small circles where the shading was slightly different would have been the scan positions. And the combination of GPS for external and IMU for internal allows for a seamless transition from inside to out and lets the pre-registration remain accurate. And that is an example of a final product that you're able to capture in per scan time under 5 minutes with the ZNF Imager 5016 unit, the blue workflow, and the hub of forensic mapping.
Well, thanks very much, Chris. We'd like to open it up to questions. If anybody has any questions about ZNF scanners or directed to Chris in particular about this presentation. In the meantime, while we're waiting for questions, I have a couple things that I thought might be of interest to the audience. One of the things I was most interested in, Chris, is ZNF working on any practical applications of this thing, plugins related to forensic investigations, things like time and speed, distance calculations, bloodstain pattern, integration with forensic video examinations, those kinds of things?
At this time, what ZNF is trying to do is, instead of having our software attempt to be a catch-all where we try to do everything, instead we're trying to partner with software that is already in use by law enforcement right now, so that they can integrate our SDK into their software so that new users are able to maintain the software that they use, just acquire the new technology for gaining the data, and then in the drag and drop format be able to take those scans directly to the software that they already know.
I think that's a good approach. One of the other questions I had, I think the mosaic retake is probably one of the most unique things I've seen in a scanner recently, and cosmetics are always important to folks in forensics. We have to present this information to people who are of limited experience with 3D documentation and crime scene investigation in general. So we want it to look nice. So that is a fantastic feature. One of the things I was curious about, you guys have an 11 exposure HDR capability. Can you also change exposures in those retakes?
No, the settings would remain the same.
Okay.
The only thing that would be different is the scanner immediately goes to the position for those two mosaics and just retakes the image. The setting would remain the same. So if you take it at the fast setting where it's 2 exposures, it's going to take the retake photo at the same up to 2 exposures.
Okay, thank you for that. How about deliverables out of Laser Scout? Do you guys focus on just getting the point cloud out to things like VESAs, or is there a deliverable short of a point cloud that we could give to folks out of Laser Scout?
You can. The idea behind Laser Control and Laser Control Scout is that we give you the ability to immediately view your data, register it, ensure that you have complete coverage of the scene of interest, and then from there you can run any kind of filtering that you need, take measurements while you're in the field and everything is fresh and in front of you before a dynamic scene is apt to change. And then from there you can save it and then export it out into whatever format you need for the next stage of the process. So like I said, we're not trying to be a catch-all where none of those products really seem to stand out in any one application. They can just happen to do all of them. We just give you the ability to get the best point cloud possible while you're out in the field and then take it to the next step. So that's why there's roughly, I'd say, 15 different export formats, so that the software that you're already using right now will be able to take that point cloud and you can immediately start working with it.
Okay, thank you, Chris. I have a question from the audience that's a couple questions actually that are interrelated. Can you discuss a little bit about the thermal capabilities of the scanner? And then an add-on to that is the thermal data exported with the RGB data?
The thermal camera is an attachment that would go on to anything on the 5010 series, as well as will be available for the 5016 unit. So your thermal data is essentially another layer. You would have your XYZ values, you have your RGB values for color, and then you have your T values. You can open those in laser control, and you're able to view essentially a colorized point cloud with temperature data. You can acquire the temperature in 4 different ranges. If you know you're looking for something in an industrial environment, they're looking for hot versus cold pipes, they would pick the higher end of the temperature values that are available. And then from there in the software, you're able to further refine the temperature. If you want something that is only between 212 and 214 degrees Fahrenheit, you're able to narrow that window down and change the scale of the colors. From there, the export capabilities is right now something that I'm not sure what other software is out there that would be able to handle those, but you do have the ability to hold on to just those temperature values. For right now, you can take images, screenshots, or anything of that kind of the scene with the temperature values put in them. And every pixel is given both an XYZ, an RGB, and a T value.
Okay. Just one more thing. I assume that we can operate the scanner independent of a tablet?
You can. You don't need to use the tablet. The tablet is sort of the second part of the Blue workflow. So the tablet gives you the ability to immediately view the scans and start the registration process. If you decide you did not want to use a tablet, don't have one handy, just want to go out and take the scans. With the scan itself, you're also able to, on the touch screen user interface, be able to move the placement of your scans, draw the connections between them to sort of lock them down. And then from there, when you take it to, in a traditional workflow, back to the office, your scans are already pre-placed and pre-registered, meaning that you don't have a cluster of scans stacked on top of each other or sort of put in a circular fashion that you would have to sort through and put the puzzle together. So you're able to pre-place all of those on the screen. The other thing of note is that it's a two-way communication between the tablet and the scanner. Anything that you do on the tablet in terms of your registration is immediately recognized by the scanner and corrected and adjusted. So if I move a scan completely away from where it was on the tablet, I walk over to the scanner. By the time I get there and I look at the top-down view of the scene on the scanner interface, it's already moved to the placement that I just put it to, and that's where it's going to stay. The draw to that is, in a dynamic environment, someone might get called away from the scene to go to another scene because you're low on manpower. The ability to have one person be verifying and registering the scans, and then they have to leave, that two-way communication opens it up so that the next person who's going to take over their position can immediately connect to the scanner and be working on the same data set that the last person left with. They don't need to leave the machine behind that they were working with. Maybe that's their desk, their laptop in their vehicle. That goes with the vehicle. They obviously can't remove it and leave it on the scene for someone else. It's as instant as connecting to the scanner, and then that job is immediately uploaded to your new project, and it is exactly the way it was when the last person left. There's a license housed on the scanner for the Scout software. It's able to be opened by anyone in your department. You're only open to one person at a time, but anyone can use it.
Okay. I have a couple other questions that came in. One of them is related to pre-registration. Actually, both of them are related to pre-registration. It seems to me that full registration is going to take place after the export of the point cloud. Is that correct? Or is it fully registered on Laser Scout?
You can fully register in Scout. So the idea behind Scout is to pre-register your scans together to avoid having to go back to a scene. A lot of times you don't have that ability. You're in a time-sensitive environment in forensics. If you're out on a highway, you need to clean the highway up so that traffic can get through. So the pre-registration happens automatically. It's a cloud-to-cloud pre-registration. You don't have to have targets. If you do have targets, you can run a targeted registration. You can pick manual points in the field. So you can use street signs, anything, you know, a reflective marker on a highway barrier. You can pick those points to use as a reference and sort of get your registration a little bit tighter. So there's about a 10 millimeter, you know, average cloud-to-cloud registration. If you have targets, you can get it down to, you know, roughly say 5. If you have targets with survey included, you can further that down to well under a millimeter, depending on the quality of your survey targets and how many of them you have. The other thing that Laser Control Scout has available as an option is plane-to-plane registration. Any flat surface will be broken down into as many small planes as possible. A wall in an office environment might be broken down into 1,500 different individual planes, and those are used for a registration. That can be used at around 3 millimeters deviation.
So what the second part of that question, and it looks like possibly a third part as well, how does pre-registration work on multi-level buildings, is being asked.
Okay, so in an instance of a multi-level, you're scanning 2-3 stories. The IMU is able to register your forward momentum. There's an arrow on top of the scanner. If I go back to a picture of the scanner there, we could see that there's a handle on the top. Essentially, you want an overhand grip on the handle, pick the scanner up, and as you swing, it registers your momentum. There's also an altimeter in there. So everything that you do on the ground floor is going to come in with scan circles that are roughly the same color. As you change in altitude...
We're not seeing your screen, Chris, if you're trying to show something. I think we're on the end of slideshow.
Okay. As you change your altitude, you also change the color of your circles. So from a top-down view, you're able to see, and I'll show you on that video. You're able to see the scan positions as different colors. As you would change altitude, each floor would show up as a different color.
I see.
So as soon as it gets to here, I'm going to pause it for you so you guys can kind of see what I'm talking about in terms of the colors. There's also a legend that is available on the side. So opening this button would open a legend, and it'll give you the meters. Essentially, you're giving your project a height overall. All of my scans fall within this amount of height. So if you are on the first floor and you have the legend on, given a somewhat flat floor, you should be within 2 meters. As you start going up, you're going to notice that that elevation change starts to get greater and greater and greater the more floors you add. Each individual color essentially just means you're on a different level. So right now we're at a 0. We're coming in at a roughly yellowish orange color. If I change elevation, I might go to a light blue, to a light green, to a dark green, and all of the positions are going to be correct to where they are in space to the project.
So it's just heat mapped by elevation so that we can sort those things out.
Correct. And that way you would know you don't want to register a blue scan to a green because they might be next to each other, but they might be 2 floors apart.
Okay. And then I think the last part that's interrelated to this registration question is, in your experience, how accurate is the IMU from walking from one position to another, and what are its limitations? You know, on the picture of the, or in the video of the church tower, one of the things that struck me was that that was the only vertical feature there. Is that fully registered based off of GPS and IMU, or is it based off of other things?
I'll start with the GPS. The GPS being used for the outdoor pre-registration, it is by no means survey grade, so it's not accurate down to thousandths of a foot like you would need for a survey application. Instead, it's about as accurate as your cell phone, to be honest. It's within about 5 feet. The idea behind that is not to give you an exact GPS location of your scan setup. Instead, it's used for a rough direction and distance between each position. So as I'll let the video play and you can kind of see how this works. Indoors, it would be the IMU. Here we see the gentleman pick it up with the overhand view, and he's carrying it in a natural fashion. The IMU is registering his forward momentum, and it's giving him a rough placement based off of his distance and angle from position to position. So how that actually works in the field is you don't end up with a whole lot of scans stacked on top of each other at the origin position. Instead, you get a rough pre-placement, and then once the scan is taken, a cloud-to-cloud algorithm happens in the background, finds common features, and then tightens those two scans together, which will happen here in a second.
Those vertical planar features are factoring in pretty heavily there.
Right. So here we can see we have two walls. They don't match, but we have a rough distance from position 1 to position 2. And you can see this scan position color is sort of the yellowish orange, and this one is blue. As I let the video play through, now we can see we have blue, green, green. The elevation change in there might not be much, but the scanner is taking the scans, transferring it to Scout. The cloud-to-cloud algorithm pre-places your scans and then tries to make it as tight as possible. Where the cloud-to-cloud has its default is if you're in somewhere with a repetitive pattern, it doesn't know whether to match it. It might be a little off to the right, might be a little off to the left, or it could come in with a little bit of an overlap. So that's where you would want to use Target. But in a basic application for forensics, you're on a crash scene, your divider rail in between the highway is going to be perfectly enough to use for the cloud-to-cloud registration to accurately place your scans. You also have the ability with the button down here at the bottom called Connections that I can draw a connection between one position to the next and then lock that in, as well as choose the area that that scan is able to be moved. I can lock it in position. So once I know these two are good, my pre-registration, I'm able to see those values by kind of hovering over the line drawn in between them. If I know that's good, I can lock those two down so I know they're not going to move when I take the next scan.
Mm-hmm. All right, I think that's as about as thorough an answer as we could expect from that. Thank you very much, Chris. I don't have any more questions. I want to thank everybody for attending and thank Chris for his time and effort in giving us the presentation. Again, this will be recorded and available on the IAFSM website, which is iafsm.org. Thanks so much.
Thank you.